Video tonight. Make sure you can hear okay. Just check here real quick. What do I need to do? Maybe I need to like reopen this. Anybody there? If you're in the window and you can hear, oh, okay, we're live, I think. Well, welcome everybody to Emerald Hill Skies. My name's Doug. We're located here on the outskirts of Louisville, and it's great to have you here tonight. Just want to give you just a quick big picture view of the telescope. We're working off of a pier that's outside, about 200 feet out in the field outside my office here. We started by putting that pier in that you see being poured there, and then you can see the big picture of what resulted, the sidewalk and the little concrete pad and the PeerTech Telestation 2 observatory there. Peeking out of the top, you might be able to see our Roe-Ackermann-Schmidt astrograph telescope, our RASA 11. There's a little sign beside the observatory, and this is what the sign says, Emerald Hill Skies, and it says, a quote from Psalms, it says, "He determines the number of the stars and calls them each by name." This observatory has a roll-off roof, and it uses a little garage door opener that we fashioned to be able to roll that roof off, and then there's an adjustable height pier that raises the telescope up so that the axes upon which it rotates are just barely above the rooftop. And that allows this Roe-Ackermann-Schmidt astrograph telescope, this RASA 11, to be able to spin around and see almost down to the horizon. And you can see the horizon around the outside edge there. That adjustable height pier, you get a good look at it there, the way it's raised up. And on top of that pier, there is, here's another picture of that adjustable height pier, by the way. On top of that pier, there's a black mount that is an Ioptron CEM70G mount. And that's what spins the telescope around in various directions. Then at the end of the telescope, there's a ZWO ASI 2600 MC Pro one-shot color astrocam that's located on an Octopi Astro, kind of a fitting that connects it to the telescope and allows us to make some adjustments. On top of the telescope, there's an equipment plate that's riding up on top of there, and that equipment plate has on the front of it a sky cam that allows us to be able to look out at the sky. Let me see if we can get that sky cam for you. Let's see, how can we show you that? Here we go, let's try this. There we go, there's that sky cam view. And you can see most of the clouds have blown away according to our prayer being answered. But that is a very strong amount of Louisville light pollution there, isn't it? There at the bottom. Incredible amount of light pollution. And we're going to try to take out a lot of that with the filter that's on the end of the RASA 11. That filter is a Celestron light pollution filter that helps a lot. This mount that I was telling you about, it's that black machine kind of thing that's in between the pier and the telescope. That's what points the telescope in various directions and allows us hopefully to be able to zero in on the exact locations of the stellar and deep sky objects that we hope to be able to see tonight. At the bottom of the scope, there's a case that we affectionately call a rig rack. And inside that rig rack are the various power supplies, some homemade, some store-bought, that allows us to be able to power the scope and be able to operate the scope via the Wi-Fi using this specialized mini computer that's at the base of the scope. This little mini computer doesn't even have a screen. It really doesn't need one. But that computer is what's really guiding the scope and taking the pictures and then we connect to it from here inside the office via Wi-Fi, and that allows us to be able to see what it is seeing. So we showed you a while ago the sky cam view, and now let's try to zero in on the view of the, this is the ZWASI 2600 MC Pro view, and what we're looking at here is the planet Jupiter. And there's a lot of atmospheric turbulence, as you can see. The seeing is being, kind of tortured by all the different movements in the atmosphere, and you can kind of see those images kind of dancing around the wind and the upper atmosphere movement, but you can see Jupiter's 4 moons. And let's see if we can figure out the configuration of those moons. Let's see. I know how we can do that. Let's go back to this view, and let's see if we can look at Stellarium. Here we go. And let's zoom in on Stellarium here. There we go. So those moons are going to be on the side that has 3 moons. Those moons are going to be Callisto, Io, Europa. And then on the opposite side, where there's just 1 moon, it's going to be Ganymede. So somebody try to remember that order. Callisto, Io, Europa, Ganymede. Okay, now let's switch back to the live view. That's the planetarium mode. So Callisto, Io, Europa, Ganymede. So now you can say you've seen the 4 largest moons of Jupiter live. How about that? All right, now let's get into the targets that's just kind of a warm-up. Let's get into the targets that we were hoping to go tonight and see some of the deep sky objects. But before we do that, let me just look and see at some of the folks that have visited us here. We've got Wendy there. We've got John Lebrec from Western New Mexico. Good to see you on board tonight, John. We've got Tariq Astrophoton here. Very first time with us. And Tariq, you might tell us where you're observing from. We've also got John Morgan. Be sure and tell us where you're observing from, John. Larry, I'm trying to remember. You're from out in boy, remind me, Larry. I'm so sorry. I'm kind of out of practice here. Is it Montana? Tariq is hoping that he can have an observatory someday. We hope you can as well. John, thanks for the encouragement here. We've also got A.A. Gifford, and John Morgan saying some very encouraging things about. Okay, John, you're from Toronto, and Tariq, you're from UAE, from Ajman City there. It's great to have you aboard from the United Arab Emirates. So not technically Dubai. You're from the Ajman City side of things. Oh, John, you were just saying hello to Toronto, but actually you're in Hazard, Kentucky. Okay, Tariq, I hope you can get the Rasa 11 someday. It's great to have you guys aboard, and we're looking forward to you helping us observe tonight. Let's get started with a target from our list here. What we're trying to do is look through the list of 1,001 celestial wonders to see before you die. And this book, of course, is by Michael Bakich. Is it Bakich or Bakich? Bakich? I think that would be Croatian. And I always get my Croatian mixed up. I think it would originally have been pronounced Bakich, but somebody else can correct me if I'm wrong. Let's find our way back to maybe, Oh, let's start with something a little higher in the sky. Let's start with maybe this galaxy, and it's at 51 degrees. So what we'll do is we'll set it on the scope cam, and then let you watch the, oh, that's not very scopish there, is it? Let me see if I can get that tuned up. There we go. Now, let's go back and slew. Slew is just another word for move. Let's move to NGC 6015. NGC 6015, and that's target number 406 in Bakich's list of 1001 celestial wonders. I'm going to call him Michael, so I don't have to continue to try to remember how to pronounce his name. 406. And that's NGC 6015. And it says it's not quite 4 degrees west north. It tells you where to find it. A large oval haze with central brightening. And the central brightening takes up about 30% of the diameter. Maybe you'll see a little bit of structure with some faint knots. K-N-O-T-S knots. Okay, and then we're gonna do some live stacking here on this object. So we're gonna say prep for imaging. Oh, you know what we should do first is we should make sure we're on the target. So let's do a plate solve. And if you've not been on the channel for a while, remember plate solving is when we compare what the telescope's seeing to what is in the database of our software called SharpCap. SharpCap is both our imaging software and it also helps us tune in the location of the object. Okay, so hopefully we've zeroed in. Tell you what, let's just double check that we have. We'll do this plate solve only, and then we'll use deep sky image annotation to see, and right there it is, NGC 6015, supposed to be in the middle of our screen, sure enough. So let's turn deep sky image annotation off and go now to imaging, and we'll do, this is NGC 6015, and SharpCap will start taking one picture after another, and these pictures are 20 seconds each, and then SharpCap in its brain, in the brain of the software, it will stack those images and average the light points of those images, and the darker points and the places where there's like tingly atmospheric disturbance, it will average those down. And the light points, the places where it keeps seeing pixels that are illuminated, it'll say, oh, those must be the important part, and it'll start averaging those up. So it's not truly a laying the image on top of each other like I used to think. It's more of an averaging of things. And as we average things, it will help us be able to see the objects in the screen a little bit brighter, and right away, after just 60 seconds, you can already see NGC 6015. It's very small, but let's just start zooming in on it there in the middle of our image. You see there's a lot of confetti left, all this grainy atmospheric disturbance. Some of this is sky glow. It's just the atoms of the sky being lit up by everything from diffracted sunlight all the way to the light pollution that's here in the edges of Louisville. But already after just 100 seconds, we can see a fairly interesting view. You can see that central core of this galaxy. And if we're not mistaken, look at how that might be one of the arms starting to form up after just 120 seconds. So again, remember, this is a live view, but it's kind of like enhancing the live view by taking 20-second exposures and then averaging them together. And this whole process is called Electronically-assisted Astronomy, or EAA. We'll stay on this object just maybe 4 minutes, but while that's averaging, let me see what else is going over here in the conversation. Tariq says, we have clear skies here, but my life isn't. For years, no imaging. So sorry about that, Tariq. Larry, Bowling Green, Kentucky. That's right. Good to see you again, Larry. Tariq says, I have this amazing book. So that must mean you have the 1001 Celestial Wonders book. That's awesome, Tariq. And Tariq is asking what others in the community here might have for equipment. And Tariq is saying he'd like to buy a camera, but without an observatory or permanent pier, it's not as handy. Stan, good to have you aboard. Welcome. John says he's got the pier and can do photography from it now. Tariq says, can we increase the sound? Okay, let's see if we can do that. I'm going to try to turn that up what we can. Okay, we'll see if that's any better. Actually, I could experiment with raising, no, that's already up. I don't know if I can raise the transmitter gain. Tell us how that's, see if that's any better, Tariq. There, Nesrain has an 8-inch Edge, a Celestron Edge HT with AVX. That's a nice telescope. John loves Sharp Cap, really easy to learn, and is saying this is fast. Yes. So about 4 minutes now, you can see quite a bit of structure in the galaxy. Now, I have not adjusted anything other than the auto histogram adjustment and the auto color band adjustment. Now, I think that's actually not bad. I'll just play with the mids here just a little bit. Actually, I like what SharpCap did by default. Let's take these darks and let's just try. I'm going to hold the Shift key down so we can fine tune that. I'm going to make the background sky a little bit darker, and try one more time increasing the mids. That's brightening up a little bit, isn't it? So now you can see, look, you can see a few of these knots, KNO, KNOTS. Little faint, let's go beyond our optical zoom. Now we're at 160% of our optical zoom, but look how we can see some of the knots in the galaxy, little bright areas where there are brighter stars. So let's do a quick observation of this now. And we're using Astroplanner to make this observation. Indeed, just as Michael Bakich predicted, we could see after 5 or 6 minutes some of the structure arms of the galaxy, and some of the knots, the brighter stars and components. Beautiful spiral. So Michael's theory is that you really shouldn't think about dying until you've seen this galaxy. That's his theory. So I don't know if you agree, but that's, I'm just going to save, because I don't think we've ever visited this galaxy before in the history of Emerald Hill Skies. I think tonight might be video number 250. We've actually done a lot, maybe 170 nights of observation. Let me just see real quick. 172. This is night number 173. But this is actually video number, I think, 250, because we've done extra videos that didn't go with observing nights. So in all of those 250 videos, 173 nights, this is the first time we've ever seen NGC 6015. If this was if this were to be the last target, then now we'd be prepared to die, wouldn't we? But this is not the last target. In fact, we have 426 more targets to go. So let's hurry up and get started on the next one. Another target that we're supposed to look at tonight is NGC 5965. So let's stop the live stacking. And let's slew over to NGC 5965. And while that's slewing over, we'll put you back on the scope cam. And I'll check our queue here. A little bit better. Hope more if you can. Okay. Let me think. How do I adjust the transmitter that I'm using? I've got the gain all the way up, I think, in OBS, the software we're using to pick up the mic. And we've got the mic. Oh, look, there's the transmitter gain. Boy, I think all I got was 1 decibel out of that. Bummer. I don't know how else to raise this. I'm going to try moving my mic up a little closer. John, thanks for the encouragement about the pier. We love this adjustable height pier that PeerTech, that Vito makes there at PeerTech. Can't say enough good things about it. All right, now let's come back to the live view and let's plate solve again. And again, what we do when we're plate solving is make sure that we're looking correctly. We were 0.15 degrees off. So what it's going to do now is adjust those last 0.15 of a degree. And when that settles, we'll go up here and check to make sure we've positioned correctly. And there's NGC 5965, should be right in the middle of the screen. Sure enough. So now let's switch over to live stacking, which, as you can see, we're going to have to do to see this object. And this is NGC, what was it again? 5965. 5965. And it is object number 400. There goes a satellite across the screen. This might be one of Elon's. Thank you, Mr. Musk, for beautifying the night sky for us with your beautiful Starlink satellite trail. So apparently we're in Draco here. And it's an edge-on spiral. So we're looking at it like from the edge of the frisbee of the spiral of the galaxy. 4 times as long as it is wide. Okay, let's see what we can see here. What we might do is look in Stellarium. And what we can do in Stellarium is we can say, in one push button, we can say Stellarium sync. And it automatically synchronizes Stellarium with Astroplanner, which is a special script written by our friend Pete over on the Isle of Wight off the coast of England. Pete, hats off to you for writing the script. I'm afraid, though, that in Stellarium, there is no artwork. See how it is just dark. So nobody's ever posted a picture there. Which means this is kind of an exotic galaxy. Let's look at some of the facts about it. It is 3 arc minutes long and about 1 arc minute thick. How do we know that? Well, see, here in Stellarium, there is a size listed. And then down here in Astroplanner, there's also a size. But the Astroplanner size is listed as a little bit longer. Astroplanner says it's about roughly magnitude 12. And that's indeed what Stellarium says, 12.4. So let's go back to the live view. I get that by coming here. Boy, we're not seeing too much of it here, are we? Let's zoom in here. Oh, look, there's the target. Let's do another. Oh, that's a little better, isn't it? Now what we're doing when we do that is we do a kind of a reset, and then we do an auto stretch using SharpCap's imaging histogram down here. Then when we go down here, we do a reset of the color balance, and then an automatic colorgram using the histogram peaks. And Stellarium has this thing really dialed up. So I'm going to probably just try to help us back off a little bit. I'm going to hold the shift key down. Take just a little bit of that confetti out. That's too much, isn't it? We just have so much sky glow and not enough live stacking yet. But we are pushing the mids in order to see this. It looks like a flying saucer, doesn't it? You see the really bright core, and then this frisbee type disk. Again, we're looking at it edge on. Okay, some folks on the conversation there on the chat queue are talking about a way to clean optics. So we'll let you guys visit on that. I'm going to take a picture of this and we're going to push on. This is our first time to visit this galaxy as well. We're going to say beautiful edge on, 3 degrees or maybe 4, I'm sorry, arc minutes, or maybe 4 and just 1 arc minute thick, we could see the bright core and the arm structure quite clearly. That's beautiful. Looks like a UFO, doesn't it? Okay, now we're down to 425 objects to go. Hurry, 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 hurry. Let's go to NGC 5885. I'm going to set our exposure back to 3 seconds again and go to NGC 5885. This is object number 381. He says 5885 tells the location. It's in Libra. Nearly uniform faint haze. Can't see the elusive spiral structure. You only find that after long exposure imaging. Okay, so 5885. It almost sounds like that when we see it, it's not going to be very interesting, but let's take a look anyway. You know what I want to check? Let's go here to the, what I want to check here is in this display histogram. Am I right that we should turn this off and we should just be using the main imaging histogram, right? If you guys have experience with SharpCap, I always get that mixed up because that display histogram does sometimes seem to be making a difference. John's saying there's a supernova in NGC 5907. That would be cool to see, John. All right, so let's make sure we're in the right place first. Oh, we were almost a degree off in this part of the sky. Now, once it settles, the mount is moving a little bit from that last adjustment. Okay, now we'll do plate solve only. Check and make sure 5885 is in the middle, and it is. Now we'll start. You can see with just 3-second exposures and 400 gain, we see nothing. So now let's start live stacking, and this is 5885, is it not? 5885, is that right? Yes. NGC 5885. These sequences are like Lego building blocks in SharpCap. And they allow us to combine steps that we would have to do one at a time. So it pretty radically speeds up your processes. You can already see the galaxy right there in the middle. Let's do another live stretch. That's better. And let's do a color balance. Now let's zoom in on this with our digital zoom. Boy, you can see why he said it's just a faint glow. Isn't it amazing that, let's see if we can figure out how far away this is. Let's sync with stellarium and then dash over to Stellarium and see if there's a distance given for this. 100 million light years. No artwork in Stellarium, meaning it's another one of those exotic galaxies that nobody's ever taken the time to post an image of in Stellarium. It is a rather faint splotch, isn't it? If you were lucky enough to have a 12-inch telescope, you would have to go out to a very, very dark sky region of your... I mean, here in Louisville, there's no chance of seeing this live with a 12-inch or whatever scope. You have to go about an hour and a half to the south, and there is a Bortle 1 sky remaining. Here in Louisville, we're about Bortle 6, where we're observing from at Emerald Hills. Bortle 6 skies. There's no way we would see this if we were just observing through an eyepiece. Only through the magic of EAA can we see this. John says yes. He turns off the display histogram in the margin there and uses just the live stacking histogram. Okay. John's saying some really nice, encouraging things about the Rasa 11. And yes, you guys are talking about cleaning. We've never tried to clean this Rasa 11. I've heard horror stories of people messing their scopes up by trying to clean them. So it's been out there in the observatory for, I think, is it 3 years now? Yes, I think 3 years. We've had this 11-inch Rasa. Before that, for 2 years, we observed with an 8-inch Rasa. And when we got the observatory 3 years ago, we sold the 8 and bought the 11, and we wouldn't touch it. So, yeah, you guys are right. It's just so easy to scratch it up. Well, that's 3 minutes and 40 seconds. And sure enough, Michael's predictions are true. You know, maybe if I were a guessing man, I would say that there is a spiral arm here. And maybe a spiral arm here. Look, see that starting to come out? That's after 4 minutes. Over here, there's a shorter arm. Tell you what let's do. Let's go see if we can find like a Hubble photo of this. So let's go to... Going to be just a brief, I'm going to make this exchange just a little bit less abrupt by coming here first, because this screen would be, I'm going to say Hubble NGC 5885 and see if I can find it first. Okay, that's actually not bad. So now I can go back. Okay, so this is that arm that we're starting to see in the live view. So I think I can toggle now between these, can't I? See, there's that arm that we're starting to see after 5 minutes. But to get back there, I have to go like this. And then over here, this debris that we were seeing, see how there's not as much here, but we were starting to see these little stubs. See these little stubs and this debris here. I just want to draw attention that EAA rocks. Michael Bakich, this is in the observation for this target. Michael Bakich was saying that even with a 12-inch scope, we wouldn't be able to see anything other than a splotch. But with an 11-inch scope, combined with the power of EAA, we saw structure arms after just 5 minutes. This is 12th magnitude. Three or four arc minutes wide. EAA rocks. I tell you what, I cannot imagine trying to observe this anywhere near Louisville with a visual eyepiece. It would just be impossible. Well, there's not much to photograph here, so I hope you'll forgive me if I don't. Oh, I'll go ahead and take a picture, just because it does represent a bit of a proof for EAA. And then let's set it back to 3 seconds. Go back here. 424 objects to go. Oh, by the way, John was saying if we went to NGC 5907. So let's see. If I go like this and say NGC 5907, we've already observed it at one point, but let's go to it anyway, since John pointed it out. So here we go as soon as I get us off of that galaxy. There, back to our scope cam, and then back to this view. This is the Splinter galaxy, NGC 5907. Corin, good to see you again. From Barbados, welcome. Nesrain says, it should be called EAV, Extra Astronomical Vision. Haha. It's a good way to look at it, Nesrain. You're very kind to encourage. Honestly, it's a lot of fun. Let's go here and do our plate solve only. And I need to get in the habit of using the keystroke Alt-D, the shortcut key. 5907. Wonder why that ended up. Oh, I know why. I didn't plate solve. So you notice the galaxy wasn't in the center, but it wasn't too far off. 0.4 degrees off. Much better. 5907. Now let's start our stacking. So we're going to go to prep for imaging only. And this is NGC, what was it, John? 5907. 5907. Let's see if we can find any observation notes we've made before. Why am I not seeing this? Observations logged. Obviously, they should be, oh, shouldn't they be down here? Observations 4 logged. Well, that didn't work out very well. We lost our little observation window. Let's go back to objects again. And it's 59. I've lost it, John. What is it again? Is it 5907? 5907. NGC 5907. Find again. Find 5907. Now how do I see past observations of that? Do I have to go to the observation database? Shouldn't I be able to see observations? Well, right now I've messed up my window. So let's just go, to save time, let's just go to the observation database and those are sessions. NGC, but that's only going to find the 5907. That's only going to find the. I need a list of I need a list of targets. How do I do this? Let's see. Observations. 5907. One of the problems is when I use the mini computer, there, I almost had it. It won't let me see a double-headed arrow. There it goes. Okay, now we're getting somewhere. So on May 13th, 2021, we just said observed. First night using longer run USB cable. Had to work out of the truck. This was the first object of the night. Edge on, could see lots of filaments and dust in the arms. Spectacular. Second observation after focusing in APT. That's it. So really not much have we ever logged about this object. Okay, sorry about that little betting trail, but I just had to look up the past observations. Meanwhile, we've been stacking here for 4 minutes, so we didn't lose this time. Let's do an auto, and let's do a stretch, a color band. That's beautiful, isn't it? Okay, so now the question will be, John, which one of these dots is the supernova? So can we find that out by going to John says EAA is the only way to go. Laugh out loud. Supernova 2026 KID, whoa, what's that? Is just to the left of center. So is it this or is it this? I'm at work. Oh, John, I gotta go. He left. John, we're going to trust that you're going to come back and view the video later. Oh, you're in scope cam. Sorry about that. Thanks for telling me, John. Okay, so now we're back live. John Lebrecht, thanks. Okay, we need to figure out which one of these little spots is the supernova. So do we need to go to the web to find that out? Is that where we're going to find that? I always forget how to get back to the web. It's right, so it's 5907, right? SN 2026 KID. How to find SN 2026 KID. The Type 2 supernova discovered April 22nd, so what, 3 weeks ago, by Yasuo Sano in NGC 5907. So look for 5907, located just south of the core of the galaxy. It's 15.6 magnitude. That's not very bright, so it's not going to scream at us. How about if we look at Astrobin? There's 5907, but this was imaged, but it doesn't tell us which is the, oh, maybe this does. Okay. So it's right in the center. So there's that starish looking thing. Here's this starish looking thing. It's the one that's right in the center, opposite these two. Okay, let's go back and see what we can find. I'm going to set that back on telescope. Okay, here are the two, so it must be this. That's insanely bright. Yeah, John already identified it. I should have just asked John Lebrecht. He said, Doug, it's the one on the right. Wow. Now this is 100% of our digital zoom, but let's zoom in a little bit more beyond the digital zoom. That's 175%. So you're looking at an object that has only been visible to us here from Earth for about 3 weeks. Isn't that crazy? Now let's find out how far away this is. So we'll do a Stellarium sync and then go to Stellarium, and the distance is undocumented here. Let's go back out to the web and let's distance to NGC 5907. .5 to 50 million light years away. 46.5 to 50 million light years away. So this is a live view. This is a live view of an object that about 14 49 or 50 million years ago hosted a supernova explosion. A star exploded, and when it did, it created such a ruckus that we were able to see it for the first time ever. That happened 50 million years ago. And that was 3 weeks ago. 50 million years, just 3 weeks ago, 50 million years ago. And tonight, these photons are hitting the mirror of this Rasa 11 telescope that's out there in the observatory and bouncing into this ZWO ASI 2600 INSEE probe, and then they're coming to you, and you're seeing them for the first time, as I am, a live supernova. Isn't that crazy? That's crazy. Okay, so I'm going to say, quick observation. NGC 5907 was absolutely stunning in and of itself. But we were able to catch a supernova that was just discovered 3 weeks ago. Of course, this means that it exploded some 50 million years ago. And I'm going to put in parentheses, apparent time. And the name of the supernova is SN 2026 KID. Absolutely amazing that we can see something that's apparent time, 50 million years old. Now, I always say apparent time because the universe is not a clock. It's a bunch of space-time stuff. And we all know that there are places in the universe where time doesn't follow the rules that we have here on Earth, so nobody knows for sure if it's of certainty 50 million years ago. But the appearance, according to what we see here, it looks like 50 million years ago. Some people think the universe was only created 4,000 years ago. Maybe God created it as in motion when he made it, like a program when you come back after a presidential address and you're coming back to your program in progress. Maybe we're seeing this galaxy in progress and this supernova exploding in progress. Depending on your interpretation of when the universe began, it probably began with something, either God or however you want to interpret that. I happen to believe that it was God. So when God made it, did he make it in motion? See, that's the question we have to face. If he made it and it's existed all this time, then we're looking at light that's 50 million years old. So thanks to John for pointing this out to us. So we're going to save a picture of this, of course. Amazing. And then we're going to go back to imaging only. And that observation's saved. So let's get back up to where we were. And let's start looking at some of the other targets. Did I not ever? Oh, I think I did the wrong thing. Let's do this over again. I put it on the wrong setting. pause, 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 pause. Set exposure to 3 seconds, what I meant to do. Okay, let's do a couple of double stars. This is Epsilon Lyrae. It's at 29 degrees above the horizon. So let's go visit Epsilon Lyrae. Catching back up. The chat queue over here is talking about buying the right scope. And they're saying it's basically a rabbit hole. You keep upgrading. I'm just thankful that we've stayed on the same scope here for 3 years. Let's hope we can do it for a while longer. We're going to plate solve first. It took me what felt like years just to get this scope tuned correctly. I don't want to have to tune another one. So look at the beautiful double star right there in the middle of the image. Right here in the middle of the image. Just going to zoom in. Looks like a pair of car headlights, doesn't it? Now actually, Epsilon Lyrae, if I remember right, it's 2 doubles. So let's go read about this. It's 553. Object number 553 in Michael's list. Now it sounds like I'm calling him by his first name as if I know him. It's 553 and 1001 celestial wonders. How's that? Most observers call it the double-double. It's a pair of double stars that lie close together. You'll see the initial double nature, and you might think, oh, double star. You're half right. Point a telescope, and you'll see both stars resolve into pairs. Okay, let's see if we can do this. What we're seeing now is that get back on the right target here. I lost it because I clicked on something else. So how do I search for this again? Can I just go double, double, and will it find it? It did. Okay, we're clicked back on the right place now. Thank you, Elon. Let's back off this just a little bit to our 100%. Now you see what's happening now, I think, is that we're overexposing. So let's back off of our gain to maybe 100 gain. We're at 400 right now. And let's cut our exposure down to maybe 1 second. Hmm. 500 milliseconds? Aha, now we're starting to see the double-double. See how there's a little target off to the side here and a little target off the side there. Let's go down to 250 milliseconds. A lot of sizzle in the atmosphere. Now it's just so dim. So the best we're going to be able to hope for Just too much sizzle in the atmosphere. But I think with this sizzle, you're able to see that there is a two-object dance going on here. There. Every once in a while you catch a good enough view of the separation. But once we get the exposure bright enough, then the glare occludes the second star in each case. What do you say we try plate solving this just to see how that works? Just double, double. Just to see what happens. I think at 20 seconds it's going to be too bright. But let's just see. Too bright. So what if we brought this back down to the 500 millisecond level and cleared the stack and started over? So what we're learning here is that when you have a bright target like these stars, first, plate solving is not helping us if we don't have the exposure set so that it allows the object beside the glaring object to come out. That's 100 milliseconds at 100 gain. What if we go with 50 milliseconds? And then some of the fact is that these are magnitude 5 objects. It's just so bright. Oh, you know what else I can do here is play with these histogram bars a little. So in this case, it actually can help us. Okay, now we're not doing bad. Look how you can see separation now up here. And a little bit of separation here. Boy, I wonder what the angular separation is between the second doubles. Tell you what let's do. Let's go to our sky atlas for a second. And can we search here? Oh, I know how we can search. Is by the object number. The double-double is object 553. And then I think the atlas we want is oh boy, that's not what I want to do. It's going to have to recalculate now. This program's called Sky Tools, and I'm still kind of learning how to use its atlas. There we go. Oh, I did it again. Evidently, you have to left click it. I'm hitting the right click, and that's causing it to recalculate. Let's try left clicking it. It's recalculating now. And it is 1001 objects in the sky atlas is a lot. No, that didn't help us. How do we get to this? I just thought I had this figured out the other day. I think the shortcut was A. Yeah, there we go. So here's the double-double in the sky atlas that Sky Tools gives us. Now, let's zoom in. Boy. There. And what we want to know is the angular distance between these two. So if I click on this one, and then what's the shortcut key for angular distance? Oh, here's where the right click is. Angular measure is A again. And then you measure it down here. It's just 2 arc seconds. Let's look at the other one. So we're going to click on the one and then hit the A shortcut key. Whoops. A. Whoop. For some reason it's not working now. Ah. 3 arc minutes. So is that, oh, this is the double-double right here. Sorry, I was measuring the wrong thing. So these are 3 arc minutes apart. Now let's zoom in on one of them. No. So these, That's Epsilon 1 and Epsilon 2. Sorry. This one is wider, isn't it? This one is angular measure. That one is 3 arc minutes apart. Whereas this one is 3 arc seconds apart. How about that? So let's get rid of this now. How do I get back? Let's see. Let's get back to where we belong. Get back to where we all belong. Let's just minimize this. There we go. So this must be the one that's 3 arc minutes apart, you think? And this is 3 arc seconds? Could that be? Go. Quick observation. We could barely split the double with our RASA 11. We're sure that a longer focal length scope would be a better fit for this target. But by live stacking at 20 milliseconds and 100 gain, we could see the split when we zoomed in to 340% of our camera's maximum optical view. Still, it was pixelated, of course. See the pixelation? We're looking at individual pixels there because we're at 340%. Okay, I have never been much of a double star guy, but I'm growing in my respect for it. All right, let's stop that live stacking and go back to regular exposure. Let's go back to our target list. Tariq, I see that you're wanting to learn about plate solving. The most amazing thing is that SharpCap takes care of plate solving for you. So you really don't have to be as much of an expert as we did even 5 years ago, because now it's all just incorporated into SharpCap, which is amazing. Thank you. What's his name? I'm so sorry. I've forgotten the name of the writer. It's not Thomas, the developer of SharpCap. Remind me, guys. It's not Thomas. Oscar, Thomas. Robert, right? No. You don't have to use another app. You can do it within SharpCap. And if SharpCap needs to download a database, it'll help you through that. It's really, really well done. Is it Robert? Yeah, I don't think Nina's going to be as easy for this application. Okay, here's something at 18 degrees. Let's see how we do on a lower horizon object. And again, it's a multi-star system. So let's slew to that object. We've got about 38 minutes left in this observing session. We're going 10:30 to 12:30 tonight. Boy, if it's 10:30 p.m. here, oh, so in UAE it must be like maybe 6:30 a.m. for you, right, Tariq? Okay, so we're pretty well. You can see how the sky in this particular part of the sky is very, it looks sort of washed out, doesn't it? Let's take a look at our sky cam for a second. And you see why. We're down here into the sky glow. Again, this would be so hard visually. So this is the target. It's Alpha Geminorum. So let's zoom in. And reduce this to 1 second, or try our look at that. We can tell it's oblong, can't we? But look at the sizzle. Boy, I don't know how we'll ever see this. Okay, there's so much sizzle, but let's try live stacking this. We just don't have a proper It is actually improving some, isn't it? This is a Rasa hack. Live stacking at 100 milliseconds. Just to see that this is an oblong star. Let's read about this one. Object 44. Just think, you wanted you to see this before you died. Object 44. It's one of the brightest double stars in the sky, but the separation between the stars is quite close. So crank the magnification. To most observers, the primary is white, the secondary is pink. It's Castor, one of the twins. Castor, the friendly, bright double star. Boy. What do you guys think? Tariq says it's almost 8 a.m. Yes, Tariq, we're using a RASA 11 on an Ioptron CEM70G, and we've got it kind of permanently mounted inside the observatory. Walter, good to see you again. So Tariq, we did a polar alignment using SharpCap 3 years ago, and we haven't touched it since. I'm kind of playing around here, guys, to see if does anything I do help us split these stars. We're trying to use a handsaw to saw through a metal plate. The RASA was not designed to split double stars, but having said that, every once in a while, you can definitely see that it's not just a star pinpoint. Okay, so I'm going to do a quick observation here. I'm going to say, rats. We're seeing firsthand the weakness of a RASA with such a short focal length. And I'm going to put in parentheses, i.e., in other words, that is such a wide field of view. The RASA has a field of view that's 2.5 degrees wide. So just by definition, by the time you get this small, we could only see that Castor is oblong, meaning that it is a double, but we never could create separation between the two components. Despite all our 100 millisecond stacking gymnastics. It's just that it's so bright, that's the problem. Let's stop stacking. And see how every once in a while, when the sizzle is just right, we can see the separate star? Actually, without live stacking, at 100 milliseconds and 100 gain, there was so much sizzle in the air with atmospheric disturbances that every once and a while there was separation, but only for a moment. Yay. So who says you can't split Castor with a Rasa 11? It's just that you have to be a little patient and wait for the atmosphere to help you out or something. What do you guys think of all this? Thank you, Tariq. All right, let's drop back out to, let's set on 3 seconds again. And let's have a look at our next object. So starting again, look, we're into the treetops. So that was hurting us too. We were in the treetops. And by looking that close to the horizon, we were seeing through multiple atmospheres. So that's another problem. So let's get back up to something like another double star. Iota Cancri. Iota Cancri. Got about 27 minutes remaining. Oh, you know what else? We've got some clouds rolling in. Look at that. See some of those clouds passing by? So that's not helping us either. This is much easier. This is more of a Rasa 11 style double star. Look how we can already split it. Woohoo! Let's read about this one. 94, object 94. It's a great target for any size scope. The primary shines yellow and its companion is blue. Does anybody see that? Now that he mentions it, maybe. Let's decrease to maybe 1 second. That didn't help. Unless you have better color vision than I do. Easily split. I'm not sure I'm seeing the colors as clearly as a person with accurate color vision. The larger component is supposed to be yellow, and the smaller blue. Anybody see that? I'm not sure I'm seeing it. Maybe if I imagine it. Maybe. All right, how about here's a galaxy called Sextans B. That sounds exotic. Let's go there. Okay, so Nesrain did see the colors. Faint, but yes. Okay, and Walter. Walter was the one who said faint, but yes. Let's snap back out to our auto width and plate solve. Uh-oh. Okay, there we go. Oh, I'm starting to yawn. Excuse me. 23 minutes left. Now let's make sure we're on the right target. Okay, this is a case in which this is such an exotic galaxy, it's not in the SharpCap library. So here's what we do in this case. We go back over to Pete's really cool script that he programmed. And we click this button called SharpCap DSA. And then we come back to SharpCap, turn on the DSA with the hotkey, Alt-D. We go down here and say Paste Custom Object Info. So thank you, Pete. What this allows us to do is grab the coordinates from Astro Planner and paste them in the right configuration into the Custom Object Info button, which I would have never used in SharpCap because it's too technical on the fly like this with EAA. But Pete enables us to be able to do this. So sure enough, we're plate solved correctly, and we're going to look at this section of the screen. So let's get rid of, now if I hit Alt-D, does that go away? It doesn't. So you can use Alt-D to put it there, but to get rid of it, you have to click it off. Now let's go to our stacking, and this is called Sextans B. Sextans B. And it's object number 127. It's a member of our local group. At 4.5 million light years, it sits right at the outer edge of the small collection of galaxies that contains our Milky Way. Through a 12-inch telescope, you'll see a rectangular smudge of light, dotted here and there by faint foreground stars. So the foreground stars we're going to see aren't really a part of it. The central region, about 1/3 of the galaxy's diameter, is ever so slightly brighter than the outer regions. By the way, the name Sextans B is an example of a radioastronomical name. Such a label combines a constellation's name and an uppercase letter. Letters start at A and descend in order of brightness in radio wavelengths for such galaxies within a constellation. Astronomers John Bolton and Gordon Stanley introduced this system in 1950. So it was probably discovered using radio astronomy, which is really interesting. So it dodged all of the Herschels down through the years and all the other Palomar visual observers, and it took a radio telescope to find it. That's interesting. Okay, so we're going to do a reset. I think I see the beginning of it there. Boy, look at the clouds passing through the frame. I know what you're thinking. You're thinking, what? There's nothing there. But there is. Can you see the faintest image of a cloud there? And it's not, okay, maybe there are clouds there. There are clouds. But look, the clouds are moving. See? But we're going to look at a cloud that's not moving. This right here. And you're thinking, Doug, you're dreaming. But I'm not. This is a result of, after using this thing for quite a while, Oh, that's a better view. You begin to imagine where the thing is that you're looking for. And at first it feels like your eyes are playing tricks on you. But later you realize, no, it's really there. It's right here. I'm holding the shift key to adjust this. That doesn't help. That might help. After a while, you begin to see imaginary things, don't you? What we're looking for is right here, right there in the middle. We're at 4 minutes. I'm just going to say we could barely begin seeing the faintest hint of a rectangular cloud. No wonder this escaped the Herschels. There have been a couple of Herschels that have cataloged stars, but we still couldn't make it out. I'm not sure we could have noticed it among the sky glow, however. Right there. Oh, Walter says he sees it clearly. Nesrain does too. Like a cotton ball, exactly. Well, that's encouraging. It's just not my imagination then. Okay, let's go back here and look for Alpha Leonis. It's another double star. Oh boy. Okay, let's stop stacking this. 15 minutes left. We're headed to Alpha Leonis. Fasten your seatbelts. Here we go. Alpha Leonis is object 133. It's at 32 degrees up. Triple star, features magnitude 1.3 Regulus A, which is really bright, and the much fainter pair BC. B shines at 8 and C glows at 13. B and C are 4 arc minutes apart. The A component is 177 arc seconds away from them. I don't think we're going to be able to see these. It would be a miracle. See, I doubt if those are the stars that are part of the double. I bet those are just other systems. This is object 133. Let's go back to this and go to object 133. my goodness. Is this correct? Because he doesn't split in this. Unless, oh look, there's C and there's D. Oh, okay. So let's do the angular thing. Yeah, almost, but not quite, 3 arc minutes. So there are 2 stars there. We are splitting it. Look at that. This one is so much easier. So that's a C and that's a D. Do you guys like double stars? I'm just curious. I've never been much of a double star guy. I guess in a case like this, I just don't get as excited over a multi-star system. Should I? Anyway, we split these easily with the Rasa 11. They were miles apart. Memphazino Andretti. Do double stars create gravitational waves? Are you guys on the scope cam? I am so sorry. Please forgive me. That's unforgivable. What I understand is that in a multi-star system, the stars orbit around the center of mass of the entire system. So I think what you're asking is, are there gravitational waves of the movement of the stars? And the point is, in between these 3 stars, somewhere in the middle, closer to the bigger one, see, there's going to be a point of center of mass, and the stars are orbiting around that center. I'm not aware of other gravitational waves. But by the way, Nesrain says, I love all stars. Star clusters, doubles. It's just, he just enjoys all star systems. So anyway, this is an easy one to separate. That's at 26. Oh, no, I'm sorry, that's 31. Let's go to this galaxy, which is called Leo 1. It's at 31 degrees in, appropriately enough, the constellation Leo. And why are you not seeing scope cam? We lost our scope, didn't we? Well, that's no fun. There, we got it back. Okay. So now let's go back here. Let's snap back to the full width. Plate solve. This is called Leo 1. I bet this is a hard target. Because again, the Herschels didn't find it. The Herschels observed back when? Like, was it 1850 something? When did the Herschels do astronomy? William Herschel and his sister Caroline began doing serious astronomy in the early 1770s. The most intense time was 1782 through the early 19th century. And then you had John Herschel, so 1782 through 1807. But they actually remained active till 1822. And then there was John Herschel. He did 1816 until 1871. He was big time as well. So if you find something that neither of the Herschels discovered, it's exotic. So did we already play solve? I don't think we did. Oh, no, sorry. We must have already played solve and we're live stacking. Okay, so let's do this reset and histogram sort and then are we really going to find something here? This is challenging. I see 059091. No, that's not it. It's not in SharpCap. So we're going to copy that SharpCap DSA data. Thank you, Pete. And we're going to paste custom info. So it's supposed to be right here. Very small. That's already 119%. This could be the day the music died. Right there in the middle. Let's get rid of the deep sky magenitation. Oh my goodness, I'm not seeing anything here. Let's make the sky darker. And then pump up the mids. Now there's something there. But it's supposed to be here. It could be that far off. In my limited experience with something this small, sometimes you can be a little bit off. We're at 3 minutes 40 seconds. Let's read about this. 136. Our next target is a personal favorite of mine. It demonstrates that a celestial object can be easy to find but difficult to observe details. What makes it easy to find is its location. It lies only 20 arc minutes due north of magnitude 1.3 Regulus. But that brilliant star's glare through the eyepiece also makes Leo 1 difficult to see. At a dark site, an 8-inch telescope at 150 power reveals a faint mist that appears uniformly bright, Whatever you do, keep Regulus out of the field of view. American astronomers Robert Harrington and Albert Wilson discovered Leo 1 in 1950. So, the Herschels did their observing 1770s to 1800, and then John 18 whatever 10 was it? 150 years later, they find an object. Robert Harrington and Albert Wilson find an object that the Herschels missed. So these guys were searching photographic plates of the Palomar telescope. The Palomar Sky Survey using the 48-inch Samuel Oschen's Schmidt telescope. So they didn't even find this visually. They found it by searching through photographic plates. Okay, how about right here? Is that it? Let's try to get rid of a little more of the sizzle. I should use the shift key for fine tuning. Okay, see how this is troubled here? That's a telltale sign that you're starting to see it. Let's put our deep sky image annotation back. Right there is where it is. So, I don't know, I think it's actually bigger than that little circle is making it. I think it's this entire troubled mist. You guys seen any of it? Nesrain is talking about the Herschels and what limited gear they had way back then. And they made their own scopes and mounts, definitely. I think we're looking at this mist here. Boy, it's not easy to observe, is it? See, they have this marked right in the middle of that mist. Thinking right here. Stellarium sink. Look at that. It's just mist. Isn't that interesting? Huh. There's bright Regulus. Look at this. It's after 8 minutes. I bet that's it right here. And our marker is just slightly off. See how that's a different color? That doesn't help things. That is of limited value. You have to see this before you die. Man. Wonder what part of the sky this is. Let's look at Stellarium again and back off. So it's in the west, west-southwest. There's Leo the lion. Let's go to the sky view. Well, that certainly isn't helping matters, is it? Those occasional clouds that are wafting through. But still, look at that. See that little carved out? I think it's this entire design. I'm pretty sure that Leo 1 would seem like the least inspiring astro object ever observed. If we hang on it for another 30 minutes, we could no doubt pull out more detail. But EAA is not usually 30 minutes long. At 9 minutes, we could see some modeling, M-O-T-T-L-I-N-G, some flowing designs in the confetti sky glow. But speaking honestly, we believe this would require a bit more time to see clearly. You guys agree? Take a little bit more time, wouldn't it? Nesrain says it's maybe more visible when you back out. You might be right. Let's use the yeah, look, there is a splotch there. I wouldn't say it's anything to write home about, would you guys? It mostly went away when you zoomed in. Look at that. It almost looks like just a darker splotch. You're right, it does go away when you zoom in. Let's go out to the web. Leo 1 dwarf galaxy. Okay, so here it is. It's just that splotch. That splotch right there. It's not so tiny as that little marker is showing. This whole design here. Yeah, it's just this whole area, isn't it? Just weird design and pattern that's different than the normal confetti. I think this one would need more time. Right now, all we're seeing is a hint of a hint. This deserves a jet black sky and more time. Dwarf galaxy. You know, I think these dwarf galaxies do look like that. I've observed a few dwarf galaxies before, and I think they tend to look like this one, just a fuzzy halo kind of thing. All right, well, we are past our 12:30, so let's call it. Thank you for being a part of this tonight. We want to thank God for making this whole place so we can see all this stuff. And these huge distances, 50 million years for light to get here from a particular supernova, is just out of my mind. thank you for staying up late. All you guys. Yeah, Nesrain says, so elusive. I see a patch, but it's bigger than the area marked. Wendy says, I finally see it. Wendy, we're glad you did. You must have good eyes. Shadows of a ghost. Awesome stuff. That's a good description. It is. I'll add that to our observation. And that was Nesrain-N4K. Nesrain-N4K called it Shadows of a Ghost. Good stuff. Mike Jerry, welcome. I didn't know you were here. Mike observes from out in the desert outside of, I don't know, the California desert. Good to see you again, Mike. Mike does a monthly thing. You can search him on YouTube as well. He does at least once a month, and he's got a really nice dark sky, but he also does a stream like this. And appreciate you stopping by, Mike. Wendy, to all of you guys, we've got about 15 on right now. To all of you guys that have hung in there, thanks so much. You are what makes Emerald Hill Skies into a thing. Otherwise, I'd be super lonely right now. So thank you. If you're watching after the fact on the YouTube video, thank you for tuning in. If you don't mind, and I don't think it costs you anything, you can hit a thumbs up. Or if you want only, you could hit subscribe. And that would be awesome. I think we're at 3.94 thousand subscribers. So it'd be great to get up to 4,000, wouldn't it? If you wouldn't mind helping us do that campaign. Don't hesitate to ask questions if you're watching the video after the fact. And I try to find answers to the questions that you ask. If I don't know them, I'll try to find the answer. We'll keep working through this. 1001 celestial wonders to see before you die. I think we have 418 to go, so stop back and we'll keep working our way through it. In the meantime, God bless and good night from Emerald Hill Skies. It's been great having you. We'll see you shortly. Take care.